Okay, so we talked about expanding logarithms. Now let's go the other way. Let's condense logarithms, meaning we start with multiple logarithms and we're trying to combine it so that it's only one. Okay, and we're going to do this same way that we did expanding through examples. So let's take the first one and we'll use just numbers. So log base 6 of 4 minus log base 6 of 2. Okay, so first of all, you cannot condense if the bases are not the same. Or you can only condense if the bases are the same. So you always want to check for that. If the bases aren't the same, you just leave it alone. You just can't do anything. So here the bases are the same. So when we condense this, well, this is a negative log. So we know that from expansion that when the log is negative, it goes into a denominator. And when the log is positive, it goes into a numerator. So this is a pretty simple condensing because it just becomes log base 6. The log of 4 is positive, so the 4 is in the numerator, and the 2 is negative, so that goes in the denominator. And these are numbers, so this is easy enough to just convert to log base 6 of 2. Okay. Remember from our logs, this is saying 6 to what power is equal to 2. Now, if it's an integer and you know it, then please feel free to give an answer. Because this is not an integer, 6 to some non-integer power is 2. Leave it like this. Okay. Let's take another example. Again, this one will be only numbers. 2 log base 2 of 5 plus log base 2 of 6. So here, you get rid of your coefficients first. So we're going to bring this 2 into an exponent first. Becomes log base 2 of 5 squared plus log base 2 of 6. And then we can combine the 5 squared and the 6. So it's the product property backwards. We were adding, so now we multiply. Okay, and again, multiply this out and you get log base 2 of 150. Okay, so you want to move the coefficients into exponents. And then you're using the product or the quotient property. So when we expanded, we went in the opposite direction, which makes sense. Okay. Third example. This one we'll do with variables. So this one is going to look very complex, but again, this looks complex only because it's expanded. So it's a lot of terms. But it's only like a 2-step process. Okay, so we have 2 times 3 log base 2 of r minus 4 log base 2 of q plus 6 log base 2 of r. Sorry, I didn't mean to put a parentheses there. Minus 2 log base 2 of p, we're not done yet, minus, okay, so sorry, the video failed for a minute, so you're seeing things that weren't here. So it's minus 6, then in parentheses log base 2 of t, plus 4 log base 2 of n, and then finally plus 8, 3 log base 2 of m, minus 9 log base 2 of p. And that's it. So it looks super complex, not at all the case. First thing that you're going to do is you're going to get rid of parentheses by distributing. It's like a 2-step process, 3-step process. Okay, so if we do that, computer is a little slow. If we do that, we get 6 log base 2 of r minus 8 log base 2 of q plus 12 log base 2 of r minus 4 log base 2 of p minus 6 log base 2 of t plus 24. Let's make this a negative. Sorry about that. So minus 4 log base 2 of n. So that means that this is plus 24 log base 2 of n plus 24 log base 2 of m minus 72 log base 2 of p. Okay, so the next step is to combine like terms. So you'll see that there are many like terms here. There's the log base 2 of r. There's 6 and 12. There's log base 2 of p. There's a 4 and a 72. Okay, so it's really only 2 like terms. So what we get is, I'm sorry, I should have put this in red, but I'm not going to rewrite the whole thing. Okay. What we get is 18 log base 2 of r minus 8 log base 2 of q minus 76 log base 2 of p minus 6 log base 2 of t plus 24 log base 2 of n, and then plus 24 log base 2 of m. Okay, and our next step is just to bring the coefficients to the front. So we're using the power property now. So here we combined like terms. And then each of these becomes an exponent. And we're almost done. So we get log base 2 of r to the 18 minus log base 2 of q to the 8 minus log base 2 of p to the 76 minus log base 2 of t to the 6th plus log base 2 of n to the 24th plus log base 2 of m to the 24th. And finally, all we have to do is condense. So now we have one log. This becomes log base 2. And anything that's positive goes on top, anything that's negative goes on bottom. R to the 18th has a positive log, so it goes on top. Q to the 8th has a negative log, so it goes on bottom. P to the 76th, negative, it goes on bottom. T to the 6th, negative, it goes on bottom. N to the 24th is positive, so it goes on top. And n to the 24th is positive, so it goes on top. And that's it. Let's do one more. One that's a little bit less complex. Okay, that's the worst that you'll have it. Let's do two times 4 log base 2 of p plus 6 log base 2 of r minus 3 times log base 2 of p plus 5 times log base 2 of r. Okay, so we're going to do exactly the same thing in the same order. We're going to get rid of the parentheses first. So we do that by distributing, right? So when we distribute, we get 8 log base 2 of p plus 12 log base 2 of r. So when we distribute, we multiply. Next, we distribute the negative 3. So we get minus 3 log base 2 of p plus 15 log base 2 of r. Okay, now we have to combine like terms. So we have a log base 2 of p twice. We have an 8 and a negative 3. That gives us a 5 log base 2 of p. And we also have two r's, right? We have a 12 and we have a 15. We get plus 27 log base 2 of r. Next, we have coefficients. We move them into exponents. Log base 2 of p to the 5th plus log base 2 of r to the 27th. And finally, we condense. So both of these are positive. They both go into a numerator. So it's just p to the 5th, r to the 27th. So to summarize, first get rid of the parentheses by distributing. So that's pretty much your first step in every case. Second step, combine like terms. And remember, like terms means same variable and same base, okay? You cannot condense without the same base. Move your coefficients into exponents. And finally, condense when the base is the same. A positive log goes in the numerator. A negative log goes to the denominator. And you should have one log for each base at the end. So if you have a log base 2 and a log base 3, one log base 2 at the very end and one log base 3 at the very end. And that's it. That's how we condense.